I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we'll discuss speed time graph. Many students who have taken physics or mechanics will also get great benefit from this particular video. Here is a question which is a very common question to draw a speed time graph, but we are going to understand all the steps required to provide a complete solution to similar questions. Well, the question here is a car is traveling in a straight road. It starts from rest with constant acceleration a until it reaches a speed of v in 25 seconds, covering 200 meters. It moves at constant speed v for next 40 seconds, then travel with constant deceleration of 0.5 meters per second square until it has speed of 10 meters per second. It moves at this speed for the next 15 seconds and then moves with constant deceleration 0.4 meters per second square until it comes to rest. Find A and V, find total distance traveled by the car, sketch the speed time graph for the journey. Now let us see what should be our strategy to solve such a question. Now, the very first step should always be to sketch a rough graph. So we'll begin with that. So here you can see a rough graph, which is describing the situation given to us. We have an object, which is a car, which starts from rest. It accelerates. During this time, it is given to us that it accelerates with constant acceleration of a. So the acceleration here is a and attains a velocity v, which is capital V. Duration is 0.25 seconds and the distance covered during this time is 200 meters. So we can write distances at the bottom as shown here. So that is what we are given. Now, so what the second step should be to write the given information. Correct? And next step is to label. So label, right? So let's label. So it really helps us to communicate better when we label the diagram. So in this case, what we've done here is that uh, the next phase was to it moves at a constant speed v for the next 40 seconds. So when we say next 40 seconds, so that is the constant speed v adding 40 seconds to 25 seconds, so plus 40 seconds, correct? We get 65 seconds. We got this information, right? So this is the derived information from the question. Now, then travels with constant deceleration 0.5 meters per second square until it reaches a speed of 10 meters per second. Right. So now we are given here that the velocity at this point is 10 meters per second and the deceleration is a equals to 0. minus 5 meters per second square, right? Correct. So that is what we are given here. So it's deaccelerates at this speed to reach a speed of 10. So the speed here is 10. It moves at this speed for next 15 seconds. So this time delta t is 15 seconds, correct? And then moves with constant deceleration of 0.4 meters per second square until it comes to rest, t, the terminal. So that is the journey which we are going to follow, and that is how you could actually kind of label it, right? So we know all these parameters. Now we'll begin by analyzing each phase. So the first is O2P, where we need to find the value of A, the acceleration, and B, the velocity. Okay. Let's do that now. So between O to P, as shown here, right? So this is between O to P. What do we notice? We are given the acceleration. We need to find the acceleration. We are given the time and the distance. So we are given the initial velocity. It starts from rest, 0. And during a distance of 140 meters, the acceleration was a, which we need to figure out, and time was 25 seconds. S equals to ut plus half at squared is the formula which connects all these things. We are given the value of S as 200, and then u is 0, half of capital A for acceleration, 25 seconds, 25 squared. From here you can rearrange and then calculate acceleration as 0.64. 200 times 2 divided by 25 squared. So once you find the acceleration, you can now find the velocity using the formula v equals to u plus at, substituting capital V for the velocity, 0 for initial velocity 0.64, the calculated value of acceleration and time of 25 seconds, we get the velocity as 16. So this is what we get, velocity as 16 meters per second in the first phase, and we derive the acceleration as equals to 0.64 meters per second. Correct? Now, in the second part, it is moving from P to Q with a constant velocity. So you can multiply constant velocity with the time taken to get the displacement. And the distance, therefore, covered in this portion will be 16 into 40, which is 640. So we get this distance S equals to 640, correct? So we can write here 640, add this, and as we move along. That will help us in finding the total distance. Now let's move and find how do we analyze the portion Q to R. Now Q to R is a portion where there is a deceleration of 0.5. So we'll write A as minus 0.5. We know the initial velocity, which was capital V earlier, is 16, and the final velocity after this deceleration was given to us as 10, right? So this is what is given to us, and we are going to use this information to find the duration and the distance traveled. So first, v squared minus u squared is 2as. We can rearrange and write the displacement as v squared minus u squared over 2a. Substituting the values, we get the displacement as 156. So we found this displacement from Q to R S equals to 156. Now let's find the time during Q to R. We know the initial velocity here and the final velocity. We also know the acceleration. So difference in velocity divided by acceleration is time. V equals to u plus at is the standard formula. You can always rearrange and write it as t equals to v minus u over a. Substituting the values 10 and 16 and minus 0.5, we get time taken as 12 seconds. So the time taken here is 12 seconds. You can always add timeline. We had earlier time of 65, we'll add 12 to it, so we reach at a point where the time is 77 at r, right? So we get this point, time is 77. Now further, it moves with a constant speed for 15 seconds. You can add this 15 also, and you get a time of 92 at this particular point, okay? And this is 77 for us. So these are the two calculations which we have done about the time. We have also calculated the distance traveled up to this portion. Distance traveled for the constant speed portion is 10 into 15, since that is the duration when it is moving with this velocity of 10 meters per second. So the total distance covered here is 150 meters. So with that, we reach at the point S, correct? Now let's analyze the last phase of this, which is from S to T. So we have already calculated that the time taken to reach R was 77, to reach S is 92, and the distance which we found was 156. Okay, Now let's analyze the last portion between S to T. Initial velocity is 10, acceleration is minus 0.4, final velocity is 0. It comes to rest. V square minus U square is 2AS. So S is V square minus U square over 2A. Substituting values, final displacement is 125. So this displacement here is 125 meters. Let's find the duration during this. V equals to U plus AT, T is V minus U over A. Substituting values, we get 25 seconds as the duration in this particular portion. So adding this time to 92, which we found earlier, we get total time of 117. So the journey lasts for 117 seconds, and the distance traveled during this time we just found was 125 meters, right? So that is the total time. Now from here, we can find the total distance, adding up all the distances which we have measured so far, the distance from O to P, P to Q, Q to R to S, and S to T. So these are the distances. 200 given to us, then we found 640, 156, 150, 125. Adding them, we get 1271 as the total distance, right? So we have found the total distance traveled by the car at this stage. Now, let us sketch the speed time graph. Now, whenever you want to sketch the speed time graph, remember you have to mention two things very clearly. One is the time at each interval, correct? And the second is the speed, in this case, the velocity. Well, velocity and speed I'm using since they are in the same direction, right? So the car moves in one direction only. Right? So therefore, the total speed and velocity which we have calculated, they are in the one direction, right? So their value, the absolute value of velocity, will be same as that of the speed at each interval, correct? And displacement also, we can just add up and get the distance covered. So we analyzed in the first case that capital V was equals to 16, and that is how we got this point, and then moved at a constant velocity. Velocity decreased to in this portion, right? So we to 10 seconds, we know that, and then it decreased to 0. So we know the velocities. The challenge here is now to find the times. So these times were calculated using these different intervals, and that is how we are going to label it. So these are the two critical things which should be mentioned in your graph completely to sketch speed time graph for full marks, right? So here is a summary of our learnings from the given lesson. So finally, here is our speed time graph. As you can see, uh, time, all intervals are summarized here on the time, and the velocity which we calculated was 16 meters per second initially. Now it moves at this constant speed for 40 seconds, and therefore the time was calculated from 25. We added 40 to get 65. During Q2R, there was deacceleration, and it took 12 seconds for this duration. So the time was 77, and then this was given to us. We added 15 to get 92. We again calculated time from S to T as this deacceleration. Final initial velocities were given to us, and we added that to 92 to get 117. So the total duration of this journey was 117 seconds, where the velocity is shown in the green line right there. Perfect. So I hope that really helps you to understand how do we sketch speed time graph for a given journey. With this, we come to an end of this video. I hope it was a learning experience for you. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.